All right, this is Wednesday, April 21st, Math 65 and 76. I really like being back to grading your math papers because I can immediately see where you guys are struggling and offer help as needed. So thank you for turning your math assignments in on time, because then that makes me able to get the corrections out on time and then see where help is needed. All right, today we are on Math lesson 123, writing mixed numbers as improper fractions. So right here you can see that I've shaded 1.5 circles. They want us to know how many half circles are shaded. It's hard to see because everything is black here, but we have 1/2, 2/2, so we have 3 half circles shaded. 1 1/2 and 3/2 are actually equal. We're just changing mixed numbers into improper fractions. We have converted improper fractions to mixed numbers by dividing. So now we're going to do the opposite. And in order to do that, we actually multiply. So if I have 2 1/4, and they want me to turn that into an improper fraction, let me show you how to do that by drawing circles. Okay, I've shown you 2 different ways to write 2 1/4. So we have 2 full circles shaded and 1/4 of another circle shaded. My denominator is always going to be the same denominator even in an improper fraction. So this tells me how many I would split these circles into. So I've split all of my circles into fourths, and this is still fully shaded. I just did it so you could see it a little bit better. So this is still 2 full circles shaded and then 1/4. But as we can see, if we've divided it into fourths, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 fourths shaded. And another way to do this without drawing pictures is we know that we change an improper fraction into a mixed number by dividing. We actually do this by multiplying. So if I have 2 1/4, what you do is you take your denominator, you multiply it by your whole number. So 4 times 2 equals 8. Then you take that 8 and you actually add the numerator. 8 plus 1 is 9. And you have 9/4. And that is how you do it without drawing pictures. So let's try another one and see if we can figure that out. And if you need to draw pictures, that is absolutely fine. So we have 2 1/3. We want to change this into an improper fraction. So I can either draw 3 circles divided into thirds to figure out and count how much that is, or I can say 3 times 2 is 6, 6 plus 1 is 7, so that equals 7/3. All right, this is kind of fun. So you guys will do, let's see, A, B, C are pictures drawn. And it says, name the number of shaded circles as improper fractions and as a mixed number. We're going to do one of these together. Let's do B together. So B has 4 circles total. They want you to name this as an improper fraction and as a mixed number. So let's look how we do that. Okay. So I have 4 circles, 3 are fully shaded. So I would write 3 fully shaded. My last one is cut into how many pieces? It's cut into 2 pieces, so I know my denominator is 2. How many of those pieces are shaded? 1. So 3 1/2 is my mixed number. Now, if I were to split them all into half, because that's what my my denominator tells me to do, I have 1, 2, 3, 4, 5, 6, 7 shaded parts, and the 7/2. So that is how you would write this as a mixed number and an improper fraction. So you just need to do A and C and then do D, F. So A, C, D, F is what I want you to do for your practice problems today. And you have set 123 all or odd, and that this actually includes the problem you will need, so you don't have any extra problems. And once again, email me if you have any questions. Okay, Math 76. We are talking about square roots of numbers greater than 100 and functions. Okay, we have practiced finding square roots of perfect squares. Remember, our perfect squares are a number multiplied by itself. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, all the way forever. Those are perfect squares. Okay, in this lesson, we will find the square roots of perfect squares that are greater than 100. We will use a guess and check method, our favorite. As we practice, our guesses improve and we begin to get clues on how to estimate the answers. So if I need to find the square root of 400, okay, we need to find a number that when multiplied by itself has a product of 400. Remember, that's what a square root is. So a number times the same number equals 400. We know that 400 is more than 10 because 10 times 10 equals 100. We also know that the square root of 400 is much less than 100 times 100 because that equals 10,000. Since the square root of 4 equals 2, then that should hint that we should try with something that has a 2. Something that has a 2, and then since there's 2 zeros, let's just try 1 0. What does 20 times 20 equal? 20 times 20 equals 400. So the square root of 400 is 20. Okay, now let's try one that's not as simple. If we need to find the square root of a number like 625. Okay, since 625 is greater than 400, which we just answered, we know that the square root of 625 is greater than 20, right? We know that 30 times 30 equals 900, so it's somewhere between 20 and 30. So let's try literally in between 20 and 30. Let's try 25 times 25. And like I said, we are just guessing, and then we have to move around accordingly. 5 times 5, 25. 5 times 2 is 10, plus 2 is 12. Add our 0. 2 times 5 is 10. 2 times 2 is 4, plus 1. Add it together, and we have 625. So square root of 625 is 25. Okay? So that is, and hopefully they'll give you problems that are pretty simple to guess, and just using that method of, well, we know what this adds, we know what this is, somewhere in between here. Okay, next we're going to talk about functions. Nathan thought of a rule that would use the length of the side of a square to find the perimeter of the square. He recorded the results in a table in which S stands for the length of the side and P stands for the perimeter. So if it's a square, all the sides are the same, right? And so when we add them together, we get our perimeter. So let's show what Nathan figured out. Okay, so Nathan created a function which is defined as a pairing of one unknown. In this case, the length of a side with exactly one other unknown, which is the perimeter. We say the perimeter of a square is a function of the length of each side of the square. The rule of the function is to multiply the length of the side by 4 because the square has 4 sides, right? So our rule is if we have one side that is a 5, we multiply it by 4 because there are 4 sides in a square, and we get our answers, right? So 15 times 4 will give us, so it would be perimeter equals 4 sides, 4 times the number of sides. So we are going to say 15 times 4, which equals 60. So to complete this function, that is what we get. The number is 60. We want us to find a rule for another function. So we first have to look at the function and figure out what is being done here, so we can figure out how to figure out the other side of the function. Okay, look at this function here. We have L and M. It says use the rule, find the rule for this function, then use the rule to find the number for M when L is 7. So we study the table to discover the rule of the function. We see that when L is 5, M is 20. L is 5, M is 20. Okay, we might guess that the rule is multiplying L by 4. However, we see here when L is 10, M is 25. So that can't be multiplying it by 4. So we know that that guess is incorrect. We need to figure out another rule. We notice that 20 is 15 more than 5. Okay, 20 is 15 more than 5. 25 is 15 more than 10. 30 is 15 more than 15. So we come to realize that M is done by this. So we would say we add something to 15. So this case will be 7, and then we will get our answers. 7 plus 15 is 22. So this equals 22. So you first need to figure out what the function is, like what they're doing, and then you need to implement that. Let's try another one. Okay, find the missing number in the function table. So this tells me, it gives me x. X is 2 or 3 or 4. This tells me 3 times x minus 2 is how I find my function. So let's try one of these. So let's try the first one, where x is 2. 3 times 2 minus 2. 3 times 2 is 6. 6 minus 2 equals 4. So we see that that makes sense. So in order to find this function, we need to say 3. Remember, when a variable is right next to a number, that means multiplication. 3 times 4 minus 2. 3 times 4 is what? 12. 12 minus 2 is 10. Therefore, our answer is 10. All right, so you guys have practice problems on page 601. And then let me double check your set. It's 123, odd or all. And
have you shared that with us yet?
And both of what we learned today, both of the problems of what we learned today is in the set, so you don't have any extra. So that is awesome. All right, thank you guys. Let me know if you have any questions.